the new physics teacher.
Assalamu alaikum, students. Can you just unmute and just say your name so that I know who are there? Am I audible?
Yes, you are audible. Students, you
Uh,
can open your mic. Yes, please.
yeah. So there are two students, right? Mariam and Jasmine.
Yes, Mariam and Jazira Jasmine. We
Okay,
can
so I'm
introduce
starting.
yourself.
So I'm sharing my screen, and if there is any doubt or any problem you are facing, you can always ask questions. Okay. So now I'm sharing my screen.
Sister, kindly stop the recording and start recording once you share the screen. Okay, that is
Okay.
best. Mm.
Okay.
Okay, students,
Uh,
please feel free to interact the class. Okay, then only you'll understand. You can clarify the doubts. If we don't talk, she will not understand whether you understand or not. It's up to you. The floor is on yours. Okay, sister, start the class.
okay. So yeah, you are seeing my screen, right?
Yes, I can see the screen. Continue, sister.
Okay. So today we are going to study laws of motion. This is the first chapter that I'm teaching you in physics. So let's start with some questions. Physics is all about what are going around you. Like it is all the things that are going around you. So I'm starting with the first question. Uh, uh, it is that why does a ball stop after rolling for some time? You have always seen ball is rolling, like if you are playing or you are seeing a game or match, you have seen that the ball is rolling. Tell me. Just 1 minute. Yeah. Mariam or Jasmine, anyone? Students, you have to interact with me so that I understand if you are understanding or not.
I'm here, ma'am.
Yeah, so I'm asking you, do you seen the ball is rolling and it stop after some time? You can say it. It's okay if you are wrong. There is nothing worry about it. It's fine if you are wrong. Uh, yeah, you can say anything, like anything you understand. Yeah.
Ask me again, ma'am.
Uh, you are seeing my screen, right? Are you seeing my screen?
Yes, we can
Yes,
see the
ma'am.
screen, sister.
Yeah. So the first question that I have written, why does a ball stop after rolling for some time? So I'm asking this question. That this question ever crossed your mind? Why does ball stops after some time? It should go on. Anything could happen. Why does it stops after some time when we kick a ball? Okay, I'm going forward. The second question is why do we fall forward when a bus stops suddenly? Uh, I think everyone have experienced this. Whenever we are in bus or car and it stops suddenly, we get a jerk kind of thing. Or even if it starts suddenly, we feel that. So why these are things are happening? The third question I've written is why is it harder to push a heavy box than a light box? Like if there is a box, the heavy box is harder to push than a light box. Why these things are happening? So all these answers for these questions we will get to know in this chapter. Why these all things are happening? Why we get the jerk from when the bus stops suddenly? These all are forces, inertia, and laws of motion thing that we are going to understand. Okay, so we are starting with the concept of force of inertia. Okay, so are you getting the point?
Yes, ma'am.
Okay, so imagine you have seen a book is placed on a table, and we have seen that book doesn't move. Uh, the book doesn't move like suddenly that it goes on and on, or if a bus is running, it can't stop suddenly. It requires brakes and things. So these things tells us about that how the objects not move on its own. It required something external to move or to stop. It can't go on its own. So these are the things. It is because of inertia. The every object try to resist the motion or the rest. Like it tries to resist its state that this object is in. Like if a book is placed in rest, it doesn't want to move on selves. It required an external force to move a book or to stop a bus. So this is called the inertia. As I have written here, inertia. Let me change the color so that you can see. So yeah, as I have written here, inertia, the property of an object by which it resists a change in its state of rest or uniform motion. No object want to change its state. It required the external thing to change its state. This is called the inertia. Okay, inertia is directly proportional to its mass. Mass of a body is a measure of its inertia. That's why if there is a heavier box, a big box, if you want to push a big box, it requires more effort. Or even if it is way heavy, you can't move that box. But if there is a small box, light box, you can move it easily. It is because of the mass. If mass of the object is greater, then the inertia of that object is also greater. It resists more. That's what I have written here. Okay, is there is any problem so far? Mariam, Jasmine?
No, ma'am.
Okay. So now we are going to force. Force is simply a push or pull. Force means if you push or pull anything, like you push a gate, this is a push force, or you pull a gate, or you push any object, anything. This is force. Now force can do some things, like force can move object. If object is at rest, you can move this object with a force. Force can also stop object if object is moving, like the example of the bus. If bus is moving, when we apply the brake, we are forcing it to stop. So we can change the state, like we can move object, we can stop object. Also force can also change the shape of the object. Let's say we have a football. If we punch a football heavy, we can change the shape of that football. So force can also change the shape. Hmm. Now we are going to go ahead with the next topic, force and motion. So I have told you about force. Second thing that I have written here, force is a vector quantity. Okay, so there is three types of physical quantity. Mm, scalar quantity, vector quantity, and tensor quantity. So in a scalar quantity, there is only magnitude, not direction. Like if I say something is like 1 kg of potato, so there is 1 kg of potato only the magnitude 1 kg, not direction. It has no direction. That are a scalar quantity. Then there is vector quantity. In this, there is direction. If let's say if I am saying that I am forcing a book, I am pushing a book with 1 Newton force, then I have to tell the person in which direction I am forcing it. I'm forcing it left, right, north, south, any direction I have to tell. Let's say I write north, I am forcing it to north. So in vector quantity, we have magnitude, that 1 Newton is magnitude, and direction as well. In tensor quantity, there is magnitude and direction both. Like if we say the flow of current, let's say there is 3 ampere of current is flowing, and the 2 ampere and 1 ampere. So in this, there is direction. 3 ampere current is flowing in direction left to right. There is direction here as well. But when we add up, like 2 ampere plus 1 ampere is 3 ampere, we add up simply. Like we don't require any additional thing, any additional kind of algorithm to add up these things. We can add it simply. So this is tensor. But in vector, we require the trigonometry and the proper formula to add the vector quantity. Like if we say there is let's say 5 Newton of force is acting in this direction, and there is 5 Newton of force is acting in this direction. So when we write like the net force is going in this direction, so it doesn't write like we can't write it 5 plus 5 10. We have to do the algorithm that is required for the vector quantity. We have to use a proper vector formula to find out this. Okay, so these three things. So force is a vector quantity. Next is motion. Motion of a body is characterized by its displacement and velocity. Motion means if we say this body is in motion, it means it is moving. Like if a body moves from point A to point B, then we say it is in motion and it is from point A to point B, or it has some velocity like 2 meter per second, this velocity. So this is motion. Now, as we are studying laws of motion, so there is, uh, do you know how many laws of motion are there? How many laws of Newton's motion are there?
I think 3.
Yeah, right. And what are these?
I don't know, ma'am.
Anyone, like even one law, you know? Okay, fine. So there is 3 laws of motion, and we are going to study all 3 laws of motion one by one. Okay. Uh, so far, is there any doubt? If
Ma'am,
there
once
is any
again,
doubt, yeah, speak. Are you saying something?
teach force and motion.
Force and motion again, right? You have doubt in force and motion.
Yes, ma'am.
From where you have doubt, like which part? Tell me. Tell me the part, then I will explain that part majorly.
Ma'am, starting.
Starting like what is force?
Yes, ma'am.
Okay. So force is, let's suppose there is a book. Okay, there is a book on the table. Okay, when you push that book, what happens? Tell me what happens
It's
when
moved.
you push that book.
It, it's moved
Yeah, right, it moves. So why it moves?
because of our force.
Exactly. That push that you exerted on that book, that's why it moves. So that push is force. Now you understanding? Now, let's say the book is okay. I'm making it. Let's say the book is this. Okay, are you seeing?
Yes, ma'am.
Okay, let's say you push from this direction, from left to right direction. Okay, tell me
Uh,
in which direction book will move.
right.
Right. Okay. Let's say if you push from this direction, bottom to top. Now, in which direction it will move?
Top.
Top. So you can see that it has some direction. It is not like everything is equal. Like the I have told you this example of magnitude, like 1 kg of potato. It is always like magnitude only. But in force, you can see that there is direction. It depends where you are pushing it. The direction of that object will change, right?
Yes, ma'am.
That's why the force is vector quantity, and this push is that force. The push you are exerting on that book is a force. Is it clear now?
Yes, ma'am.
Okay, so now I can go ahead. Okay, so now we are studying about Newton's first law of motion. As you have said, there are three laws of motion: Newton's first law, second law, and third law. So in first law, we also say first law as law of inertia. So when I was asking you why uh, when bus stops suddenly, you feels a jerk. Like you suddenly feels a jerk when a bus stops suddenly, or if bus starts suddenly, then also you feels a jerk. It is because of inertia. All the object don't want to change its state. If we are in state rest, if we are in rest state, like if bus is in rest and we are also in rest, then we don't want to move. When bus starts, our body want to be at rest, but because we are sitting on the bus, we also move. That's why we feel the sudden jerk from, like, we are giving going backward because of this. Let's say this is seat and you are sitting like this. Okay, so this seat, as bus go ahead, this seat will go forward, but we don't want to go forward. That's why our body try to be in rest state, but it will go forward, but it feels a jerk of backward because it want to be in its original state. So this is inertia. As I have written here, a body continues to be in a state of rest or uniform motion. This example is of rest, and other example is when it is the bus is moving and it stops suddenly. Then we want to be in motion. Then again we feel the jerk. This is the example of uniform motion. Like if we are at rest, we want to be at rest. If we are in motion, we want to be in motion in a straight line unless acted upon by a net external force. Any object will not move if there is no external force. As we know, the book which is rested on the table will not go anywhere if there is no force. So this is only the laws of motion, first law of motion and law of inertia, and that I have told you earlier here. So, do you understand this?
Yes, ma'am.
Okay. So, this is the first law of motion. One example of law of inertia is also, have you ever gone to this kind of magic thing, like a magician try to show you that uh, there is a glass. Let's say there is a glass, and they put a cardboard on the top and put a coin on the cardboard, and they are removing this cardboard, and the coin go into the glass. Tell me why this is happening, why the coin is not going with the card, and it goes in the glass. Why this is happening?
Because of gravity.
Yeah, gravity is one thing, but gravity is responsible for only going downward. But why the coin is not going with the cardboard?
Inertia.
Right, inertia. Because it all are in rest, and the coin wants to be in rest. So when we remove card suddenly, coin want to be in rest, and so coin like it rest here, and when we remove the card, because then after removing the gravity concept comes in, but the concept here, the first concept here is inertia, that why it is not going with the card, it is because of the inertia. The second thing we all have seen in our home, like if there is a carpet, what we do to clean the carpet, we beat the carpet so that dust comes out. Have you seen that?
Yes, ma'am.
Yeah, okay. So in this also, let's say this is the carpet. We put the carpet vertically, then we beat the carpet. So what happens is there is dust in the carpet. Okay, some dust. Or when we beat the carpet, let's say when we beat it, its shape little distorted. It goes inside, but the particle in this will remain at its position. So now this one, uh, 1 second. So now this one is the carpet when we beat it, and the dust was in its original position. So dust comes out and the carpet will get cleaned. It is because of inertia. So as you can see, there is everywhere you can see the example of physics. It's physics is all about what's going around you. After this class, I want you to see around you and take examples of what are the examples of the concept that you are using or seeing in your real life. Okay.
Yes, ma'am.
Okay. So now we are going ahead with next topic, and it is okay. Mhm. Momentum and second law. So momentum and second law of motion is related. Actually, one thing. So do you know what is momentum? Any one of you?
Ma'am, a large force acting for short time.
No, that's not momentum. Okay. It's good you tried, or you should always try. It doesn't matter you are right or wrong. You should try. Okay, now I will be explaining what is momentum. So momentum tells us how hard it is to stop or move an object. Like when we move a 10 kg block, example, let's say when we move a 10 kg block, So it is easier to move a 10 kg block or it is hard to move a 10 kg block? Tell me.
Ma'am.
Hard, right? And let's say there is a 1 kg block. It is easy or hard?
Easy, ma'am.
Easy.
Easy. So when if 1 kg block to move a 1 kg block, it is easy. It means its momentum is low as compared to the momentum of 10 kg block. So my momentum tells us how hard it is to stop or move an object. So momentum tells us about how hard it is to stop or move an object. Okay, now we generally donate momentum with speed. Okay, so the momentum formula is P is equals to, I can write it like, oh shit. So momentum formula is mass into velocity. Okay. Uh, Firstly, I have given you the example of mass that 10 kg block is hard to move and 1 kg block is easy to move. Now, the second thing comes in that tell me if there is an object or let's say a cycle. Let's say a cycle is coming to you with 10 meter per second of speed and another cycle is coming to you with let's say 1 meter per second of speed, which is easy to stop,
1 meter per second.
right? And 10 meter per second will be hard to stop as compared to the 1 meter per second. So momentum is the combination of mass and velocity. That's why the formula is momentum is equals to mass into velocity, and momentum is denoted by p and mass is denoted by m and velocity is denoted by v. This is the formula of momentum. Now, can you tell me the unit of momentum?
P.
Ma'am, kg/ms -1.
Kg? Can you
Meter
say
per
again?
second. kg/meter per second.
Right, kg meter per second. So unit of this is kg meter per second. It comes from that mass unit of mass is kg and unit of velocity is meter per second. So the unit of momentum is kg meter per second. Okay. Now momentum is also a vector quantity. Can you tell me why momentum is vector quantity? Like how can you explain it is a vector quantity?
Because it also have force.
No, it doesn't have force directly. We can't say that. It's a cause of force, but we can't say that it is force. We can see here momentum is equals to mass into velocity. That momentum is equals to mass into velocity. Mass is a scalar quantity. It has only magnitude. 1 kg, 2 kg, 100 kg. But velocity is a vector quantity. We if we are saying there is two things, speed and velocity. If we are seeing speed, then it is a scalar quantity. We can say only that, let's say if we are talking about speed, we can say it is 2 meter per second. But when we are talking about velocity, we have to say 2 meter per second in which direction. Uh, just a minute. Okay, sorry for the disturbance. So yeah, we are talking about velocity. Are you listening to me?
Listening.
Okay, so yeah, when we talk about velocity, we have to always say that what is the direction of the velocity? Like we are saying 2 meter per second, in which direction? Let's say east or west, north, south, any direction. So because velocity is a vector quantity, so we can see from this formula, this scalar quantity doesn't give us direction, but vector quantity give us direction. So that's why momentum is also a direction. Okay. Now, when we talk about a force in this section, like force is related to how fast momentum changes, like how fast it changes. You can say that there is the formula for force. It is there is a formula for force, and basically it is that force is the rate of change of momentum. How fast or slow the momentum changes, that value is the force. And from here we get the formula for our second law of motion. It is F is equals to mass in, let's say first write full, then we write this. Okay, force is equals to mass into acceleration. Have you heard about this formula?
Yes, ma'am.
Okay, so how this formula came? Force is the rate of change of momentum. It means change in momentum per unit time. So P is equals to mv. If we write it change in momentum per unit time, we can write it like P by T. T's time is equals to mv by T. This change in momentum becomes force F and mv by T. We can take mass here and v by T. Can you say what is velocity by time?
An acceleration.
Right. So now we can write mass into acceleration. So from here, this formula came, force is equals to mass into acceleration. And the second law of motion is this. Force is the rate of change of momentum. This is the second law of motion, and the formula for this is F is equals to m into A. More force means more acceleration. You can see, like if we exert more force on an object, it will move fast. If we exert less force, it will move slow. So more force, more acceleration. Mass is a constant thing, as we know. Mass doesn't change. So if we increase force, acceleration increases. Second thing also, we can see that if if object is heavy, high mass, we can write it acceleration is equals to force upon m. If there is very heavy object, then its acceleration will be low. You can see it from here that the acceleration is inversely proportional to mass. From here, acceleration is inversely proportional to mass. If mass is more, acceleration will be less for the same force. Okay. From here, okay, one more thing. Now you can say about the unit of the force. Can you tell me the unit of the force?
kg, kilogram,
Yeah, kg. Say it.
Ma'am, kg meter per square.
Right.
Square.
Unit of force is kg meter per second square. Acceleration unit is meter per second square. Mass unit is kg. So force unit is kg meter per second square. And we don't generally write kg meter per second square. We write Newton. This kg meter per second square, we write it as Newton and denote it is with N. Okay. From here, you can say that if there is an object of 1 kg and if we want to move it with acceleration of 1 meter per second square, then we have to apply a force of 1 Newton to move a object of 1 kg. Okay. Is there any doubt till here?
Mm,
Any doubt?
no ma'am.
Okay. So now we go ahead with the third law of motion. Newton's third law of motion. Do you know what is Newton's third law of motion?
Ma'am, every action has opposite and equal reaction.
Right. Every action has equal and opposite reaction. This is the third law. Can you give me any example of this? Yeah, can you give me any example? No? Okay. So yeah, you said very right. To every action, there is an equal and opposite reaction, and this is the third law of motion. So the example of this is like walking. When we walk, we what we do, we push the ground with our feet backward, and the ground pushes our feet forward with equal and opposite motion. This is what equal and opposite reaction is. And because of this law, because of this thing, that equal and opposite reaction thing, we are moving. This is one pair. If second example, we can take of swimming. When we swim, what we do, we push the water backward, and water pushes us forward. This is also equal and opposite reaction. Do you understand the example?
Yes, ma'am.
Always remember that the action and reaction act on different objects, so they do not cancel. It doesn't act on the same object. It is not like let's say this is object, there is action force and there is reaction force on same object, and it is cancelled out. It is not happening like that. Action and reaction force always act on two different objects. When we are saying the example of walking, the action force is on the ground and reaction force is on the foot. So it is on two different object. So this is the very important point. Action and reaction always act on different object. So they do not cancel out each other. So, do you understand that?
Yeah.
Okay. So, these are the topics that I have to cover today. Any doubt from here? Any doubt from anywhere? You can ask. Do you guys have any doubt?
No, ma'am.
No? Okay. So now can you explain what is inertia? Can you explain this? Okay, just we do some questions uh, from this topic and then we go ahead. Okay. Um, uh, if you are not answering now, it's fine. Today is the first day and you are now learning. But whatever I teach you today, you have to learn it, you have to understand everything, and then you can understand the coming topics and chapters. So don't take it like class goes on and you didn't like understand and go ahead. You can't do this. You if you are doing this, then you'll get problem with the next topic, next chapter, and it will get more and more difficult for you. It's fine for now, but try to understand and learn it and remember all the things for the next day. Okay.
Yes, ma'am.
Okay, now we are doing some question. First question is SI unit of linear momentum. Linear momentum. I will give you the options, but I want you to answer without option so that it will get easier for you when you get answer. Can you tell me the SI unit of linear momentum? The momentum that I have told teach you?
Centimeter per second.
Right. Very good. Okay, now I am giving you exam options and you have to choose one. Tell me which option is correct.
Ma'am, option A.
Good. So option A is correct. Now we go ahead with second question. 1 Newton is equivalent to. Do you know the other unit for force? Do you know the Newton, other than Newton, what are the unit of force?
Ma'am, dyne.
Right, dyne. So do you know the relation? 1 Newton is equals to how much dyne?
10 to the 5.
Right, 10 to the power 5. So which option is correct?
And option
Right. Now we are going ahead with third question. Dimension of impulse. Okay, this topic is not covered yet. Okay, we are skipping this. for now, we will go ahead with this when we cover this topic. Okay, this question is there. A boy have a mass 60 kg and travel with a velocity 1 meter per second, momentum of boy. Now, can you solve this? There's a question. A boy have a mass of 60 kg and he is traveling with a velocity of 1 meter per second, and we have to find the momentum of the boy. Can you solve this?
Yes, ma'am. The momentum is equal to mass into velocity, ma'am.
Okay, tell me how we can.
Mass is equal to
Right.
60 kg.
Then what is the answer?
60 kg meter per second, ma'am.
What is right? 60 kg meter per second. So there's a option A. So there is options 6. Tell me which is the right answer.
And option B, ma'am.
Right. So whoever doesn't get it, I'm doing this for them. So momentum is equals to the formula of momentum, as I have teach you earlier, is mass into velocity. And what is the mass of the boy? 60 kg. So 60. Okay, I'm telling you after this. 60 kg into what is the velocity of the boy? 1 meter per second. So 60 into 1, 60, and unit is kg meter per second. So from there, the answer is kg meter per second. Oh, I have missed 1 point. Student, you have to see this like you have chosen B, but actually there is no correct answer because of my mistake. Okay. The answer is 60 kg meter per second. The first option is 6 kg meter per second square. Magnitude is also wrong and the unit is also wrong. Second is 60 kg per second. This is correct. The third one is 60. Magnitude is correct. But when we see the unit, it is kg meter per second square. So this is not the unit of momentum. And when we go ahead with D, it is 6 kg per meter second. Magnitude is also wrong, unit is also wrong. So that's how we choose, and always take a right glance on the unit. Okay, so yeah. Any doubt so far?
No, ma'am.
Okay. So you guys have that book, right? That physics book.
Yes, ma'am.
Yes,
So
ma'am.
what you have to do for the next class is whatever I taught you today, go through all the things, read the same topic from the book, and solve all the questions in the book that are from these topics. Like there, I can see there are in between questions. Um Like there is a question, is it correct to state that a body always moves in direction of a net external force acting on it? It is the question of inertia and all the things. So there is some question, 2 to 3 questions in between topics like book completed one topic, then there is some question, then topic, then some question. It is not possible for me to take all the questions, but you have to solve all the questions, and whichever question you are getting any doubt, you can ask me in class. So what you have to do for the next class is solve all the questions that I have covered in this class, and read the topic from the book and from the class as well, and prepare for the next class. Okay?
Okay, ma'am.
Yes,
Okay.
ma'am.
Yeah, that's it for the class. You can leave now.
Thank you, ma'am.
Okay.